Good morning, class. These are our notes. We're calling them 14A notes because we're in week 14. But really, what we're looking at is we're looking at like radical terms, and just we're continuing our work with simplifying square roots. So, first, just to do a quick review about like terms. If we think about like terms, our like terms had to have the same variable and the same exponent. So I can add 2x plus 8x because they both have x, and x is raised to the first power. I know there's no 1 here, but that's what it means when we have a variable by itself. And then to add, all that we do is say, well, if we have 2 x's and we have 8 x's, then altogether we have 10x. So we're just taking these coefficients and we're adding them together. So we're going to look at applying this idea to radicals. So if you look at this first one, we have a square root of 3 and we have another square root of 3. So these are like radical terms. And I'm not saying like square root terms because remember, we can have cube roots, we can have fourth roots, but as long as it's the same root index, that's that number. Like a square root, remember, doesn't have a number, but a cube root does have a number. That's the root index. So as long as the square roots as long as the roots are the same number here, and as long as they have the same number inside, then we can combine them. So here I have a square root of 3, so it's a square root and it's a 3. Here I have another square root of 3. So again, it's a square root and it's a 3. Those are the same. So I can do exactly what I did with the x's up above, and I can take the 2 and the 8 and I can add those together. So a lot of times I'll say something like I have 2 square roots of 3 over here, and then I'm adding 8 more of them, and that makes it really obvious that it's 10. So thinking about things that are not like terms, I want to just give you a non-example. Some people learn better that way. So if I had 3 square roots of 2 and I was adding 2 square roots of 3, those would not be like terms. They have different numbers inside the square root symbol. Okay, so looking at the next one, I have 9 square roots of 5 minus square root of 5, and these can be kind of tricky ones. What we have to do is remember that there's always a 1 in front of variables like that. Still works with square roots, and 9 minus 1 would be 8 square roots of 5. So looking at the next one, I don't have like radical terms, but they're also not simplified. 7 might be simplified. 7 could only be 7 times 1, but 63 is not simplified. So let's take care of that first. So 63, we could use 9 times 7. 9 is 3 times 3. So remember, we're looking at all those things that multiply to make 63, and then we're looking for pairs. So I'm going to rewrite underneath 4 square roots of 63, I'm going to write 4 times, because this 4 is being multiplied, and then I'm going to rewrite 63. So 63 is the 2 3's being multiplied, so that's going to be a square root of 3 squared. Remember, there's a square root on our 63, so all of these parts here would have square roots, and then we have times the square root of 7, and then plus 2 square roots of 7. So right here with the 3, the square and the root, those are inverses. So that leaves us with just a 3. So then we have 4 times 3 times square root of 7 plus the 2 square roots of 7. And we can multiply these now. 12 square roots of 7 plus 2 square roots of 7. And then our last step is to add. 12 and 2 makes 14. All right, on for the next one. So on the next one, do I have like radical terms? I do not, right? One's a 45, one's a 20. They're both square roots, but we have different numbers inside. So I'm going to have to do some simplifying again. And it turns out this time, there's lots of factors inside both the 45 and the 20. We're going to have to work on both of them. So let's take the 45 over here. 45 is 9 times 5. 9 is 3 times 3. So we have a 3, and a 5. So there's our pair again. And remember, we're doing square roots of all of these because it is a square root of 45. So this makes 2 times square root of 3 squared times the square root of 5 minus, and then I'm going to break up 20. So let's see, 20 is going to be 4 times 5, and 5 is 2 times 2. So 2 times 2 times 5 makes 20. And again, we've got that pair of 2's. Okay, so square root of 2 squared, square root of 5. I'm kind of running out of space over here, so I'm going to like draw a little line to help separate my work out. So anytime I have a square and a root, I am left with just the number, because when I square it and then take a square root, I'm back to 3 there, inverses. Sometimes in math we say that they cancel each other out. That's not really a proper math term, but it makes sense to us. And then I'm multiplying these two, and then my last step is to subtract. So whenever I have that number sitting in front, it is just multiplying. So if you have trouble remembering that, think about, I'm going to flip over my paper really quick. If I have a number like 7 in front of the parentheses, this 7 is being multiplied because it's just sitting here and there's no symbol. That's what that means. So if I put something just next to some kind of math operation like that, it means multiplication. Now I can't write a 2 next to a 3 and say, well, it's 2 times 3, right? That doesn't work. But that 2 in front of the square root means it's being multiplied. Okay, so on to the next one. We are multiplying the square root of 5 times square root of 15. Since they're both square roots, I can multiply them. And it's whatever 5 times 15 is, which is 75. Okay, but obviously I can simplify that. So I know that this is, oh, I know it's 5 times 15. You might see a shortcut here. That's great. I'm not going to show the shortcut on this right now. 15 is going to be 3 times 5. So if I am multiplying to get 75, I have 5 times 3 times 5. And so there's my pair again. I have 2 5s, and then I have that leftover 3. So let's write it as the square root of the 5 squared. We always want to write the one that's squared first. We know that's going to be our whole number. And then we always want to write the factor that's left over at the end. So this is going to be 5 square roots of 3. Okay, on the last one we do together, we're just going to go ahead and multiply. And I can multiply the 2 times the 4, and I can multiply the 18 times the 24. So let's maybe think a little bit this time. So I don't really want to multiply 18 times 24, and I don't really know what it is. So what I notice over here is when I multiplied these two together, I got 75, but then I went back and I broke that number into 5 times 15. So I know if I multiply these two together, it's going to be some kind of big number. I don't know what it is, but let's call it a big number. And when I split it apart, the first two factors I'm going to get are 18 and 24. So I'm just going to go from here. I don't need to actually know what that number is. So 18 is 6 times 3. 6 is 2 times 3. Let's see, 24 is 4 times 6. I can break down the 4 and I can break down the 6. And there are just so many factors now. So I have a 2 and a 3 and a 2 and a 2 and a 3 and a 2. So I can't use this 6, right, because there's arrows coming off of it, or branches coming off of it. But this 3 right here is also the end. Same with the 4. I can't use that one. There's branches coming off of it, and the 6. But I'm left with all of these factors here. So let's see what's going on. 2 times 4 would make an 8. And then I have a pair of 2's, right? Here's a 2 here. Here's a 2 here. So that's going to be a 2 squared. Okay, and then I have a 3 and a 3. So that's going to be a 3 squared. I have another 2 and another 2. So that's going to be another 2 squared. And then what's left? I have the square root of 3 left over. So normally I'm like highlighting to show pairs, but on this one there were just so many numbers. I had to go through and kind of cross them off as I use them to keep track. So this is going to be an 8 times a 2 times 3 times 2 times square root of 3. And then we'd want to multiply all these whole numbers together. So 8 times 2 is 16. 3 times 2 times 2. So this is 8 times 12. That's a better way for me to think of it. So 96 square roots of 3. So at this point, I'd like you to pause and try these problems at the bottom. And then what I'm going to do is work them out really quick and not narrate my way through them. So when you restart the video, you're going to see me just working them out really fast. And then I'll just kind of talk about what our strategy was for each problem. So go ahead and stop now. So in this first problem, all I did was look at my coefficients, my 9 and 3, and subtract. So I have 6 square roots of 11, so we keep it the 11 inside. On the second one, I had to take 18 and break that down. And I got 3 and 3 and 2, so I had my pair, my 3's, that I wrote as a 3 squared. Remember that 4 in front was just being multiplied. And so the 4 times 3 made it 12. And then once both of these radical terms were like radical terms, I could combine them together. So remember, we're not always going to have like radical terms. That's what we're practicing on this page, and so that's what we've given you. On this last one, I had to multiply the 6 and 12 together, so that made some kind of a big number. But then I broke it back up into 6 and a 12, and I kept going from there. And I had a pair of 2's and a pair of 3's. So that's what I've got here. My final answer was 12 square roots of 2. So as always, if you have questions, please ask them in class. And I hope you have a good